Hi everyone, welcome to Behind the Biomedical Engineer, where we talk with biomedical engineering specialists about their experience in the field of BME and beyond. Today we are here with Professor Wei, a professor in BME here at WPI. Dr. Wei's lab explores the fluid mechanics of blood in relation to cardiovascular disease. He joined WPI this year, coming from Georgia Tech. His research interests currently focus on developing and applying novel image-based computational and experimental models for cardiovascular fluid mechanics. It's a pleasure to have you here, Professor Wei. So to start off, I want to learn a little bit more about the basis of your research. So how would you describe your current research to yourself as a second-year university student?
So my research, as you just mentioned, it's related to the cardiovascular diseases, and a lot of time, I mean, even now, when a surgeon or interventionalist, they want to put a medical devices or surgery or do a surgery to a patient, usually they take some level of gas, right? And then, so we as engineer, we don't like that. Okay, we like to optimize things. So my research is mostly based on how to understand the cardiovascular diseases, especially in the fluid mechanics point of view, and how to use that understanding to optimize the medical devices. And then on the other hand, is that most medical devices or surgeries are done with some general guidelines. Just like when you got a cold, hopefully it's not COVID, then you take a Tylenol, for example. But different people may have different reaction to the Tylenol. Some people maybe take one and then they are very good, but some people take two or five, then they got recovered. Which is fine for taking Tylenols, but then you think about it, when you do a heart surgery, you need to break bones, you need to open your chest and do a lot of things and put you in the some ECMO for 8 or 10 hours. You don't hear that if some patients or maybe your friends take a surgery, and after they suffer that much, the doctor says, hey, you have to do another one. Just like you need to take another 5 Tylenols, you need to do another 5 surgeries. So you don't like that. But unfortunately, most of the time, that's the reality. So our research also trying to optimize the surgery outcomes for each patient. So if you cannot really understand all these, there's something you probably understand is called digital twins. Of course, we're not really only do digital, and so we basically reproduce a patient's cardiovascular flow system in the bench or in the computer, and based on that we can optimize how would the surgery or medical devices the outcome in that patient.
So kind of something that we've discussed before, an undergraduate degree in biomedical engineering is well known for its breadth. So how do you manage the breadth and specificity of BME, specifically with your work with medical devices?
So breadth actually is good. Means you learn a lot. You can the advantage of being a student, you guys are know all aspect that you can all the knowledge. For example, I was from mechanical, so as a mechanical student, you know a lot of hardcore techniques of computational skills and so on. But when I transferred from mechanical engineer to biomedical, the biggest one is I don't even know how to talk to doctors. So as a BME, I think you have this advantage. Of course, then you don't have the technique, the depth in technique. I would say how to cover that aspect is to trying to get more involved in the project-based learning, which is what WPI is really good at.
Yes.
But if you really want to put that forward, is go attend some research, because when you really do research, how you can use technologies or techniques or knowledge from your course into a real project. I mean, when you do real projects, sometimes it's not the technique is challenging, but how to pull everything together to fix a problem. Actually, over there, the BME student has a lot of advantage, because as a mechanical engineer, I don't know how to pull the biology stuff to the BME problem, and also for example, as a double E person, who is really good at circuits, but they don't know how to pull the clinical concept to the thing. And then in my view, BME student, you guys are very good leaders when you go to when you graduate. most of my pre-students, they are like clinical coordinator, they are like R&D manager. I mean, the reason they can do that is because they know how to guide a biologist to finish the job. They can guide the computational computer scientist to finish the job, and then they know how to talk to the clinicians. I mean, so this bridge makes them, they can be a very, very good bridge to, between the clinical world and then the hardcore engineering world.
Okay, yeah, that definitely makes sense. Like kind of using the breadth to our advantage for management, but then also using research as an outlet to gain more technical skills. And kind of going off of that, where do you think the field of BME will be in 5 to 8 years?
Tie this question back to the previous one. BME actually evolved very fast, and then I would say more computational stuff will get into BME. Those AI things. I know, like for BME students, at least for now, not this. Maybe just 1 or 2 coding classes. That's all. And then for BME education, I would say definitely in 5 and 8 years.
Yeah.
The AI stuff, they will get into it, and then also for industry, AI will will really get blooming. And then for the other side, I would say there'll be more like big companies like those like Google or those. I mean, I think they already started to think get into the healthcare. So not only those like traditional like Siemens or these companies will still do good, but like those huge. But I would say they probably will get into still through the computational like AI stuff. And then one thing I found is like maybe 5 years ago, a lot of students think about like either go to industry or go to academia. Academia is graduate school. But I think in the future, in the next 5 to 8 years, more and more BME students will get into hospital. So now in hospital, not only doctors or nurses, now there's a lot of engineers. And then the BME student, like I said before, right? They are definitely you guys are definitely the first cohort of engineering should get into hospitals. Like you know how to talk to them, the engineering skills. So I think from education, from the industry, from career development, I think that's what will be going on 5 to 8 years. But of course, for research, I mean, it will still be like growing super fast, and that's why someone like me who is from mechanical get into it, because it's really like a lot of time it's like really life-saving research, right?
Yeah, that's awesome. It's exciting stuff to think about too. Thinking about some of the current research and how research is evolving right now, what's the most shocking BME headline or journal title that you've seen in your career?
I actually forgot what's the journal title, but there was a news like last year, or maybe this year, from the University of Maryland Medical School. They actually put the first pig heart into human. I mean, I'm a cardiovascular researcher, so that's basically solved everything if it works. I mean, because like we design a lot of medical devices and so on, but they are man-made artificial materials, device. They are not really biology. I mean, now there's a lot of like tissue engineering things, but think about like if you can put another heart. I know it's pig heart, but if they can make it better and then put another whole heart into human, I mean that solves a lot of problems. So it's really shocking, and then on the other hand, like put a pig heart in a human is also shocking to me. So
it's a pretty unique approach for sure. Going in to talk about failure. Failure is often hard to confront as a student and as a professional. Can you share an occasion where you encountered failure and kind of how you learned from it?
I mean, as a researcher, I mean, encounter failures every day stuff. Like we currently I'm working with my student. I mean, they cannot achieve the goals, which is totally fine. I mean, think about like when we submit the grant, right? I think I submitted more than 20 or 30 grants in the past 3 years. We got lucky and then got awarded like 6 or 7. But the failure rate is quite high. And what you do is like especially like when you get the comments from the grant. the first reaction, I don't know. I mean, maybe that's most people like, hey, why my grant did not get it, right? I mean, it's like, hey, it does not make sense. You don't understand me.
Yeah.
I think that's normal, especially for the first 2 or 3 grants, or the first 2 or 3 failure. But unfortunately, there's a lot of things like you cannot control during that failure. Just do your best, keep calm, and then do your best to improve yourself, to trying to improve together, right? I mean, for example, like it is true. It's not really biased. Like a lot of time because of the reviewer, they don't really understand what you say. I mean, yeah, you can say that, but can you really argue with the reviewer? The best way is like, how can I, right, to improve my writing, to make sure like it's better. I mean, as long as you set up that goal, then you will see like hey, you actually can improve.
Yeah.
But at the end, if you already tried your best and then you think you already did it and you still cannot get it, switch another one, right? I mean, there's definitely not like everything is you cannot win everything because of you. Like there's a lot of chances because like some random stuff comes up and then does not work. So really keep calm and then don't just keep trying. I think that's keep trying to improve yourself. But if you really cannot do it, or if something really happens does not meet your expectations, don't worry about it. This is life, right?
Yeah. Yeah, I think that's really good advice because sometimes stuff like that is kind of out of your control after a certain extent.
That's right, yeah.
You can only do so much, but it all ends up working out. If you could give BME students at any level one piece of advice, what would it be? Yeah,
I think that ties back to the second question is like, do project. That's why I also one of the reasons I joined WPI. I like the project related things. I mean, even for my other schools I stayed, I also says like I want to lead like senior project, which is MQP here.
Yeah.
Like I like to participate in MQP because I think that's the time, and now I like to encourage. That's why I also got like the undergraduate research fund because I really liked to engage or encourage students to participate in research. And then when you really get into a project or research, your whatever knowledge you learn in the class is really important, but maybe they are not practical.
Yeah.
And then to practically solve the problem, that's another level of learning.
Yeah. I think that's great advice. I feel like here a lot of my greatest takeaways have come from projects, even IQP, which wasn't really major related. Yeah. Just learning how to problem solve is huge.
Yeah, problem solving, I think, is something really hard to teach.
Yeah.
You have to make failures. You learn from it. You think about it. And then you get it. I think that's, maybe other people, smarter people can think about a way to convey that message. But most of the time, if I go back to 10 years and then to give some advice like I learned to 10 years younger version of me, I probably will only absorb like 20%. Because something like those failures you never hit, you will never understand how important it is those little tips.
Yeah, exactly. Finally, just to end off on a light note, what's the least intellectual thing that you do when not at work, and how does a BME researcher get away from it all?
I think doing exercise.
Yeah.
Researcher, no matter what, you're healthy. Especially as a cardiovascular researcher, health is definitely something I care a lot. When you see so many patients, we are trying to help patients, but when you see so many patients in the bedside, and then how hard the surgeon trying to save them, some of them because of the other problems, for example, like a congenital heart defect, they born with a defect, then you cannot avoid that. But sometimes because your lack of exercise or your diet issues, I'm not saying like you cannot eat hamburgers, but if you eat too much and you don't do any exercise, definitely will cause problems. And that problem, when you sit on the bedside, you think, oh yeah, you probably can improve before, right? I'm not saying I'm doing perfect, but trying to do more exercise is definitely good. And then also, as a researcher, I'm thinking about my research every day. I'm trying to solve the problem every day. Doing exercise is really time to escape from it, because you focus on, I like running. So when you run, you usually don't think too much about, how good or what are failures, right?
Yeah.
now is the time for running or cycling, right? Cycling.
Yeah. That's a great way to kind of factor in some of your research findings into your life outside of the lab.
Yeah, that's right. Thank you.
Yeah, thank you so much for your time. This was great.